Questions 11 through 20 on the 2005 Grade 8 AMC 8. The sales tax rate in Burgeville is 6%. During a sale at the Burgeville Coat Closet, the price of a coat is discounted 20% from its $90 price. Two clerks, Jack and Jill, calculate the bill independently. Jack rings up $90 and adds 6% sales tax, then subtracts 20% from the total. Jill rings up $90, subtracts 20% off the price, then adds 6% of the discounted price for sales tax. What is Jack's total minus Jill's total? All right, let's see what each scenario brings us in terms of a final price. Jack basically takes the $90 and he immediately adds the 6% sales tax, and that will give you $95.4. And then he discounts the 20%, so you'd have to multiply by 0.8. And if you do that, you get $76.32. All right, let's see what happens with Jill. She first discounts the 20% on the $90, and that gives you $72 exactly. And then she adds the 6% sales tax to the $72. And if you do, you get $76.32. You get the same result. So Jill's total and Jack's total, if you subtract them, well, what would you get? You'd get 0. So the answer here is choice C. Big Al, the ape, ate 100 bananas from May 1 to May 5. Each day he ate 6 more bananas than on the previous day. How many bananas did Big Al eat on May 5th? So we got 1st, 2nd, 3rd, 4th, 5th, right? 1st, 2nd, 3rd, 4th, and 5th of May. That's a nice month. And on the first day, I don't know how many he ate, so I'll just call it X. But I know on the second day he ate X plus 6, then X plus 12, then X plus 18, right? We're going up by 6 each day. And this total, if you add them all, has to equal 100, correct? All right, let's do the math. It looks like 5X. And then if you add up the numbers, it's 60. And that equals 100. So 5X is equal to 40. And then if you divide through by 5, you get X is equal to 8. So what are they asking in this question on May 5th? Well, May 5th is this number right here. So that's X plus 24. So that's 8 plus 24, which is 32. So that would mean choice D for number 12. The area of polygon ABCDEF is 52 with AB equal to 8, BC equal to 9, and FA equal to 5. What is DE plus EF? Well, if from here to here is 5, it's FA, and then that's 9, that means that this distance is going to be 4, just from the symmetry of this diagram. And these are all right angles, right? So it all is exactly going to be the same on that side. All right, I hope you agree with me. And then FE, that one I don't know, so I'll just call it X. And then therefore, this is going to be, this red line is 8 minus X. And therefore, this is 8 minus X. All right, let's work with this. So our area, they tell us, is 52, total area. Well, how do we get 52? Well, first it's this rectangle, so that's 5 times 8, and then add to that this rectangle, which would be 4 times 8 minus X. All right, so we got 52 is equal to 40 plus 32 minus 4X. 52 is equal to 72 minus 4X, so 4X is equal to 20, and therefore X is equal to 5. All right, so DE plus EF is Well, DE is, let's see here, 4. And EF, we just calculated, is 5. And therefore that answer is 9. So number 13, the answer is C. The Little 12 basketball conference has 2 divisions with 6 teams in each division. Each team plays each of the other teams in its own division twice and every team in the other division once. How many conference games are scheduled? So we've got 2 divisions, right? So Div 1 and Div 2. And then we got 6 teams. So A, B, C, D, E, F. Those are the 6 teams. And then G, H, I, J, K, L. All right? You can call them anything you want. And then the first situation is that each team plays every other team in its own division twice. So that means A will play B, A will play C, AD, AE, and AF, correct? And then B will play C, BD, BE, and BF. We don't have to use BA because BA is the same as AB. And then now if we look at C, it will be CD, CE, and CF because all the other choices are counted. CB and CA are already counted. And then D would be with E and D with F. And then finally, the last one is E with F. This accounts for all the teams playing each other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of the games. But each of these games happens twice. Okay? So that means there's 15 times 2, which is 30 games. Now, in a very similar way, in Division 2, the exact same thing happens, right? Identical to what I just did, but this time with these 6 teams right here. So there'll be 30 games there. So that takes care of the divisions. Then there's these cross-division games where every team is playing the other division teams once. All right, so what does that mean? A will play G, A will play H, A will play I, A will play J, A will play K, and A will play L. So that's 6 games. And in a very similar way, B will play 6 games, C will play 6 games, D will play 6, E will play 6, and F will play 6. 1 game with each of these guys. All right? So 1, 2, 3, 4, 5, 6. 6 times 6 is 36. For those cross-division games. And the interdivision games within the division is 30 and 30. So we add up all these. 30, 30, and 36 is 96. So 14, the answer is B. How many different isosceles triangles have integer side lengths and a perimeter of 23? So we've got an isosceles triangle and we don't know the sides yet, but we do know the perimeter. Well, if it's isosceles, that means 2 sides are the same and the third side is some other side. So 2x plus y, the perimeter, has got to be 23. And x and y have to be integers as well. All right, let's make a table, x and y, like that, and let's see what we get. Let's start with y. If y is 1, x will be 11. If y is 2, x will not be an integer. If it's 3, x will be 10. 5 gives you 9. 7 will give you 8. 9 will give you 7. 11 will give you 6, and so on. 13, 15, 17, 19, and 21. 5, 4, 3, 2, 1. Okay? So at first you think, oh, okay, there's 11. Let's choose 11 and move on. But, ooh, please don't make that mistake. Because there's a fundamental rule in triangles that if you have 2 sides, like any triangle, like if you have any triangle and this is side A, B, and C, the fundamental rule is that A plus B must be greater than C. Otherwise, a triangle cannot be made. And that rule must be followed always. So in our case, we've got a situation where A and B are both x, so 2x must be greater than y. That has to be followed. Well, which one of these scenarios follows that? 2x greater than y. This is okay, that's okay, that's okay. And I think that is the last one that's okay, because once you get to this one, 2x is 10, and that is not greater than 13. So all of these are no good. So these are the only ones, and that's 6 of them, right? Yeah. So 15, the answer is C. A 5-legged Martian has a drawer full of socks, each of which is red, white, or blue. And there are at least 5 socks of each color. The Martian pulls out 1 sock at a time without looking. How many socks must the Martian remove from the drawer to be certain there will be 5 socks of the same color? All right, so there's red, white, and blue, and at least 5. All right, at least. All right, well, this is one of those extreme case scenarios, so a little bit of practice helps with these. Basically, this is the way of figuring this out. He goes in, doesn't not look, right? Without looking. He grabs a red one, okay? Then he grabs a white, then a blue. And let's say he repeats that pattern. Red, white, blue, red, white, blue, and then he grabs a red, white, and blue. So far, how many socks has he grabbed? Well, looks like 12. 12 socks. And how many does he have of each color? Well, he's got 4 red, 4 white, and 4 blue. Does he have 5 of the same color? No, not yet. But he will the very next time he picks a sock, guaranteed. Whatever he picks, he can only pick red, white, or blue. If the next sock is red, boom, he's got 5 red. If the next sock is white, he's got 5 white. And if the next sock is blue, he's got 5 blue. So that 13th sock guarantees, is that the word they're using? Certain. You will be certain that you will have 5 socks of the same color on the 13th pick of this NBA draft. No, it's not an NBA draft. All right, number 16, therefore, is D. The results of a cross-country team's training run. I'm a cross-country runner myself. Are graphed below. Which student has the greatest average speed? Okay, well, they're labeled A, B, C, D for the names. Yeah, A, B, C, D. All right, no problem. Let's just write it below each one. We know that speed is equal to distance over time, correct? And they want you to find the greatest speed. All right, let's do that. We're probably going to have to use a lot of approximations here. So for Angela, her distance is what, about 1.5 approximately? Time is about 7. For Brianna, it's about 2.2. These are complete approximations just based on the graph. And hopefully the answer choice will be very obvious, so I don't have to worry that I didn't approximate properly. And then Evelyn looks like 4.5 over about 1.2. All right, let's figure these out. There's about 0.2, I think. This is about 0.8. This is about 1, a little over 1.2, about a half. And this is 3.7. All right, so in very obvious way, Evelyn has the greatest speed. So number 17, the answer is E. How many 3-digit numbers are divisible by 13? So it's a 3-digit number. So that means it's got to be anywhere from 100 to 999, correct? Well, it's divisible by 13, so, you know, just multiples of 13, I guess. You know, if you keep going 13, 20, 26, 39 like that, you'll eventually get to 104 as the first number that is above 100. That's a multiple of 13. And that is basically 13 times 8, I believe. And then if you keep going like that, obviously you get 117 and 130 and so on. And then all the way, the largest number, if you just keep adding 13, or you can add 130 to make it faster, right? Because, I mean, it takes forever to add 13 every time. But if you add 130, 260, 390, 420, you can get up 520. You can get up to this 999 pretty quickly. And if you do that, you'll get to 988. All right? And that is basically 13 times 76. So we're going from 8 to 76 in terms of multiples of 13. 8 times 13, all the way up to 76 times 13. So how many is that? Well, we didn't use the first 7, right? 6, ... We didn't use those. So you just take 76 and subtract it from the 7 to get the total number of multiples. And that's 69. All right, a little bit of practice will definitely help you with these kinds of questions. They're important. Number 18, therefore, is C. What is the perimeter of trapezoid ABCD? Well, the first thing is that I will draw a line from C to the bottom like this. And of course, that's a perpendicular that I just drew. So I just drew a little right angle in there. Okay, this therefore is 50 from here to here, because these are perpendiculars. And now I'll figure out AE, and then I'll figure out that little guy there. And that can be easily done by Pythagoras. And just before I begin, I will label that side. It's 30. Oh, sorry. No. Oh, be careful. It's 24. Right? It's the same as that guy. Okay, here we go. X squared plus 24 squared is equal to 30 squared. And if you do the math, pretty straightforward here. X will be 18. And then similarly in this triangle, we got 24 plus y, 24 squared plus y squared is 25 squared. And if you do the math, y is equal to 7. So we've got all the sides. Perimeter is therefore 30 plus 50 plus 25 plus our x value, which is 18, plus 50 plus 7. And if you add this all up, it's 180. And therefore, number 19 is A. Alice and Bob play a game involving a circle whose circumference is divided by 12 equally spaced points. The points are numbered clockwise from 1 to 12. Both start at point 12. Alice moves clockwise and Bob counterclockwise. In a turn of the game, Alice moves 5 points clockwise and Bob moves 9 points counterclockwise. This game ends when they stop at the same point. How many turns will this take? So this is obviously like a clock, right? I think that's pretty obvious. They figured that out already. And like any clock, it's going to be divided into 12. So I'll just draw that in. So basically like that. All right, not perfect, but it's okay. You totally understand. Okay, so here we go. Let's start numbering these just like a clock. 12 goes up here, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so let's start with, who do you want to start with? Ladies first, right? So Alice goes first. So here we go, Alice. She is starting, where is she starting? Both start at point 12. Okay, they both start at point 12. So Alice starts here, and she is moving 5 points clockwise every time. Okay, so let's start making a list of her numbers. So 1, 2, 3, 4, 5. That's her first point. Then 1, 2, 3, 4, 5. Her 10 is her second point. So 5 and then 10. And then 1, 2, 3, 4, 5. 3 is the next where she lands. 1, 2, 3, 4, 5. Then 8. 1, 2, 3, 4, 5. Then 1. 1, 2, 3, 4, 5, 6. All right. You get the point here, I hope. Let's do Bob next. Let's see where he ends up. He's starting also at 12, but he's going 9 counterclockwise. Okay. Oh boy, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 is where he ends up first. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 is where he ends up next. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 12. And then 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 6. All right. Oh, thankfully I didn't have to keep going. So by 6 turns, they end up at the same spot. So number 20, the answer is A.